Welcome to Tent Re. This is the talk, How I Made My Own Diesel Motorcycle. With me on stage is a guy who drove on his diesel motorcycle almost all the way to SHA. It broke down 10 kilometers in front of us, and he got very friendly help from police and a few other people, but I will let him tell you that story again. So please give a very warm round of applause to Russell.
Hi, I'm going to go through the basic stages of construction that I went through to produce the diesel bike that's parked outside. And because I was hoping to come on a different diesel bike that I've been building, but I had to leave it at home because I only really got it running 10 days ago. I didn't trust it enough to travel between countries on it. So really the presentation should be how I built my diesel bikes, because I'm going to cover the main engineering parts that I went through for this one, and then move on to the next one, because I did a talk about this at EMF last year. So to start with, the most common questions people ask me when they see it is, why did you go ahead and do all this? There's a lot of work, you know. And the main one is the technical challenge. It's an engineering challenge. You know, I'm an engineer at heart, although my main speciality is electronics. And secondly is the novelty. It's a bit fun to have something different, and it's unique. And mostly it's because of the exceptional economy you can get, which I'll go into in sort of numbers later. Numbers here. So yeah, basically it was the technical challenge, novelty, the uniqueness, and most importantly to me is the economy. The bike outside has a small Kabuta engine in it, and I can get a reliable 145 miles per gallon, which equates to about 1.95 litres per 100 kilometres, for another measure of economy. The second bike I'll be talking about in a moment is one that's based on a Volkswagen 1900 engine that I haven't had on the road for long enough to get a good miles per gallon number out of it, as it is still running very badly, but even then it's still giving me 70 miles per gallon, and I hope to get that up to about 110 as an estimation. Briefly, is it a new idea to build diesel bikes? Because most people who come up to me at garages or at the side of the road and say, hey, I've never seen one of those, is not really. It's an idea that diesel engines have been made in India since the 1970s. It's the only place where they've been in any kind of mass production in India. But when I last tried to check that out, I heard from someone that the legislation over there has changed, which means that the not the fuel economy, the emissions are now too great, so they've had to stop making them. The other big producers have been a company in Germany called Sommer, and they have made 500 sometime last year. They hit a 500 target. The most professional looking one is something called a Trax, and they made approximately 20 bikes that had a 800cc engine out of the smart car in them, and then he chose to close his business, much to the disappointment to a lot of people. So all of the bikes that are in production or have been made have been short runs or personal projects, and I try and attend as often as I can some annual meetings where people exchange ideas and get together, and the English one is called the Big Knock. And that has approximately 40 bikes attend every year, and that's near London. And the second one is the German Diesel Motortreffen, where approximately 50 bikes turn up, and that's been going for quite a long time now, a great number of years. So that was a bit of background. So I'll look into how I did it, and firstly is what tools I used. And you know, we all start off saying, well, I used a big hammer, and when I had a bigger problem, I used a bigger hammer. Obviously spanners, hacksaws, angle grinders for the more demanding cutting, a pillar drill. Of course, things have got to be welded together. So I have a welder, and I switched over. I stopped using MIG a while ago, and I now use a DC stick welder because I find it more convenient and equally as good welds. The latest tool I bought, which was about 18 months, 2 years ago, was I bought a lathe so I can do round things, and that enabled me to do all the turning work that you'll see pictures for in a moment, rather than go and visit a friend of mine and have to negotiate when he's in. He's over there waving now. A friend of mine with a great big lathe, and who actually the flywheel that's on the bike parked outside was cut down on his lathe. And then, of course, you need somewhere to do it. So I have a shed in the back garden. So I have a typical photo of my glorious shed, the hive of mess and activity. I have the motto, a tidy desk is a desk where nothing happens. And then if you turn around in my shed, you have the lathe and some storage. You can tell from the sort of closeness that I do have a very small shed. And the other thing is the house I bought has no rear access, so everything has to come down a flight of steps. And that's me having the lathe delivered by a guy across town who I bought it from. And we used a chain hoist and inched it down the steps. So before you start building something like this, you have to go through a few technical problems before you actually get your hands dirty. And one of them is power and choice of engine, speed you want to travel at, how you're going to transmit the power from the engine to the rear wheel with the gearbox, and of course what chassis it goes in. And for the bike parked outside, I used a Kabuta engine, which is the smallest in its kind of class of 500cc diesel engine. It's a twin cylinder. It's water cooled. It's currently in production because there's a habit from a lot of self-builders of using an old engine they got cheap from somewhere, and then something goes wrong and you can't get spares. So this engine's in production. It's used a lot in industry. So I found that a lot of main dealers are very well stocked and will supply you even the smallest, quirkiest part from the engine by return of post. This particular engine has 13.5 horsepower according to most of the spec sheets, and a top RPM of 3,500 RPM, which is enough to get the vehicle up to about 70 mile an hour on a good day with no wind. For this bike, I chose the BMW R80 frame because it had a gearbox and a shaft drive rather than a chain, which I wanted. And then when I looked at the gear ratios for the speeds I wanted to travel at and the expected top speed, it fitted in with the speed of the engine using the existing gear ratios. So that worked out quite well for this build. And you can't see it at the moment, but the bike has a very small peanut tank, which holds 1.5 gallons, which normally is unusably small, but because I get such high mileage, it's actually about right. Briefly, everyone has to deal with the law when you put a vehicle on the road. And I won't go into much detail, but for this particular build, where I haven't altered the identity of the vehicle, all I needed to do was to pass the annual safety checks, the MOT. If you do a complete dry build, you have to pass something called the MSVA, which is the Motorcycle Single Vehicle Approval Scheme. And that's a comprehensive test that takes all morning, and you would say it's expensive. It is, like, I think £300, which isn't much on the grand scale of it. And of course, if you change a vehicle engine, you have to make sure it's in the right tax bracket for paying your tax. As I said, I've made some other diesel bikes. So to briefly say, there's this, which is again built on a BMW frame with the existing, all the standard gearbox and transmission. I had to chop and lengthen the frame for this one. And then when you paint it up nicely, the MOT man can't see that, so he thinks it's standard. And this is using, I can't pronounce the name, so I won't try and do it. It's using a East German V-twin air-cooled diesel engine. It's 800cc. It weighed about 120 kilos all by itself. And was made in 1974. It was very advanced for its age. I didn't realize how old it was because it looked like a modern engine rather than a much older engine. And I had that on the road for eight or 9 months before it went wrong like 3 or 4 times in a row. And because it was made in 1974, I couldn't get spares. So I retired it. I have the chassis in the attic and everything else is gone. In fact, a lot of the things like the gearbox and the transmission and wheels and bits are probably on the bike outside, or some of them. Then related to the second bike I'm going to go into details about today is this, which is the second one I made. And it's the chassis for that was Russian Nipper MT11, which is like really big, sturdy, strong frame, and quirky enough that nobody knows whether you've cut it up and welded it back together or not, because there's a few of them around. And this has a Volkswagen 1900 engine in it, naturally aspirated, and this was on the road for I think 8 months before I had a catastrophic oil failure and the sides blew out the engine when the con rods broke. And I retired that after that. But this is interesting because it has only the clutch and then the transmission shaft to the rear wheel. So there is one gear and a clutch. And because the engine is just so torquey and large for the weight it's moving, that you slip the clutch a bit and that gets you going. And once it's doing 20 mile an hour, you're fine in the traffic. So that was quite fun to ride. It's by far the roughest one I've made in image. Yes, there's the one that was on the main title slide, which I'll do some details about. And then the last bike I've built is again built based around a 1900 Volkswagen engine, but this one has the turbo on it and a gearbox, and I'll go into that in much more detail in a moment. I'm not sure why I put that slide in. That's a random slide. I've been really busy, so I only wrote this presentation at the weekend here at SHA. So the main engineering problem with the bike outside was the fact I've got one engine from an industrial application and the gearbox from the actual motorcycle itself, and I had to mate those two together. I had very limited space because I wanted to do this particular project without cutting the frame. And as I said earlier, I go to the German meeting with diesel bikes, and they're always interested because we talk about how relatively slack it is in the UK and how relatively tight it is in Germany, and they run into major problems if they cut or weld the frame. So I restricted myself by trying to build the one out there, and I managed it without cutting, welding, extending the frame or altering it in any way, to see if any people over there would be confident enough to copy the idea and save themselves a whole raft of legislation and paperwork. So because of that, mating the gearbox and the engine together was done at the flywheel. There wasn't the room or the space to make an adapter, so what I had to do was to take the flywheel over to my friend Richard's house and turn it down on a lathe, so it matched the profile of the flywheel that was on the original engine. And if you're not aware, the diaphragm spring, washer spring, that's in the center of a single plate clutch like this has a very narrow movement of operation. So the depth and distances that they had to be turned down to on the lathe had to be really quite accurate. and I managed it, and there it is with the clutch of the gearbox mated to the flywheel. And there's the issue of then, I don't know if you can see that's too dark, the issue of then attaching the two together, because you've got the shaft of the engine and the shaft of the gearbox, and if they're out and then the clutch engages and they spin, you'll just destroy the splines or the clutch plate. So of course everything has to be parallel, which is what I'm setting up here. And for that I simply used straight edges and a vernier caliper to do that. Then checking that the two shafts are in line was slightly more complicated, and I had to resort to using proper dial gauges, which was quite tricky because I had to make sure that with it all aligned, that I could check the concentricity of the spline. This is with the clutch plate missing, so we're looking at the spline of the gearbox here, and then the flywheel. And luckily on this build, the gearbox clutch is actuated by a rod that goes down through the center of the shaft of the gearbox. And the shaft was, I think, 8mm, the original push shaft. Because it's a well-made BMW German gearbox. The center bore hole was bored out to exactly 9mm, so I bought myself some 9mm ground steel rod, filed a slight, or turned a slight taper on the end, and it dropped right down the middle, and engaged, dropped down the middle and engaged in the hole in the end of the shaft, which allowed me to align the two together because it was physically aligned by this rod I dropped down through. What was I doing here? And then to test that it was actually concentric, because the engine and the gearbox were both bolted to a plate, a big face plate, and then I welded struts between the two. But before welding the struts between the two, I had to make sure that the two lines were the two shafts were in alignment. So I took it apart, reassembled it all with the clutch in place, engaged the clutch, and then with the dial gauge between the two plates, turned the engine shaft, the engine crank, and then when it was out of alignment, these two plates moved round as I turned it by hand, which I looked at the dial gauge and then tapped it with a hammer until I could turn the main crank without the top plate moving. And then once I was convinced it was all in alignment, I welded it up, and it stayed like that forever. And again, yes, there's another dial gauge photo, making sure it was all concentric. So that was probably the most challenging engineering part of it, because without that, it wouldn't have driven for more than a few miles. And I know other people who've done similar operations and got it just a bit wrong, and they have a lot of fun because they have to take it all apart and remanufacture it. Then it was aligning it in the frame. There's the frame with the gearbox now mounted to the engine, and I have to get it so as it fits in, which is it's not quite apparent in this photo or the next one, but I've had to tilt the engine over by a few degrees, and it's also raised up by a few degrees so as it misses all the frame tubes. And also, with it moving around, I had to make sure that the output shaft, flange of the gearbox mated with the shaft of the shaft drive to the rear wheel. And to give an idea of how tight it is, the front part of the engine casing almost rubs on the frame there, and you can see where the paint is scratched from just moving it around, getting it into alignment. So, it really was a very tight fit and almost didn't go, and there's the one on the other side. And you can see the nut here, you can probably get a few sheets of paper through it as clearance. But because if I didn't get it within the frame like that, I'd have had to cut and alter the frame, which I'd have got away with, but it would have defeated the whole design plan of getting it going. The next part was mounting it. So once I very carefully placed it in, and using chocks of wood to hold it in place, I then temporarily put a spotter weld at the bottom of the chassis to one of the mounting plates on both sides, and then at the top of the engine. And what that did is it held the engine in place temporarily whilst I made templates out of card that went between the mounting plate of the engine and then the original holes where the original engine was mounted. And again, I could have easily welded tags to the frame, which would have sorted me out. But the idea of this build was to do it without altering the frame at all. And then those templates were transferred to sheets of steel, mounted up in place. It's a 2 parts there with a line, then welded up. And of course, with welding, there's the obvious hazard of fire. So it's the old fire. And the shed was so small that I did a lot of the work down in the shed and then assembled it all up in my spare room where it caught fire. So you have to be quite careful and have fire extinguishers on hand and buckets of water. And the rest of the bike is really just a lash up of spare parts, but just concentrating on the engine conversion. And then that produced the bike outside, which I've had on the road for 4 years. I mean, admittedly, I've had to put a couple of new engines in because I've had catastrophic engine failure, but I think that's just a function of buying cheap second-hand end-of-life engines to start with. At least I'm saying it is. And as far as reliability is concerned, when I first put it on the road, I had a different alternator that had a lay shaft and some badly made bearing housings, and the bearings would fail and the belt would snap or the bearings would just seize. And that kind of initial problem went away when I designed it away rather than tried to repair it. Since then, I've used it every day to commute. I do a round trip of about 70 miles every day, which for the last 4 or 5 years, it sort of stacks up to quite a staggering amount of miles that I've kind of done on it. Despite the fact it broke down 10 kilometers from SHA, and I had to get some friendly help getting here, which was great, because if I'd have called my recovery agent, I'd have gone home on Thursday night and missed everything, including this presentation. The other things people notice looking at the bike is I have a tow ball. One of the things I tow around is my dog in the barrel, and she's got a harness on and strapped in, and occasionally I'll put goggles on her. So it's a vehicle I use all the time, which is the bike outside. So I was hoping to get through that a bit quicker, but I'll move on to the second bike, which is the one I wanted to ride on, which is the one I've made over the last 18 months. And he's a much more of a self-build than a conversion. And the parts I used for that was a Volkswagen TDI 1900 cc 4-cylinder engine that are very common. You can pick them up for a reasonable amount of money, and that has a everyday book power of about 110 horsepower, which is then tunable. For the engine control of that, I've used a DIY electrical control circuit, basically ECU computer, which I'll go into not much detail, but slightly more detail at the moment. I've based it on the Dnieper MT11 frame from the previous bike right at the beginning of the presentation. The reason I did that is I've already registered that as a diesel motorcycle with the DVLA, with the government. So if I use that same frame, it's already got the paperwork changed on it. Only this time I've heavily modified it, so it's not to circumnavigate that. It's just that that the numbers match. I've also used the actual gearbox and the clutch from the original gearbox that was made to go on the TDI engine. And I did that because of the amount of effort and work it was building the flywheel and doing the conversion that you just saw. So the first thing I did was to get hold of an engine, which meant going to a scrapyard, and they were all hilarious. They found it hilarious that I turned up on a little tiny motorbike, which is the diesel bike, with a trailer, and you can't see it now, but the engine's loaded on the back. And they'd never seen anything like that, so that was quite an event out. And the main thing I did was basically cut the frame open, so as I've got the three sort of parallel beams in it, and the engine, and went through a process of aligning everything and lining it up and checking the layout and the look, and so I can visualize where all the parts go. And here I have the engine with the gearbox lightly bolted to it and part of the frame, the transmission, just to lay it out and get a feel for it. And the alignment as well is something to take into consideration a lot, because I don't have a jig. I think for the next bike I build, we'll have a jig that will hold the front wheel and the rear wheel absolutely in position. Then you build everything around it. Whereas what I did with this is I put guidelines and straight lines and spirit levels just to make sure they're in alignment. And what I've done here is because it's such a heavy machine, this one, I wanted the engine in the center. So quite conveniently, there's some bolts on top of the cylinder head that I put some risers on, and then I've got a pole that goes right the way through. And that was my center line of the bike that I used as a reference point, which again can be seen in the next slide here. And I could take measurements from that to make sure it's kind of pointing in the right way. And then once I was happy that the engine was sat squarely in the frame, I welded or made these little tags up that were then welded on. And one of the things I did here that was quite fiddly but proved enormously useful is there's, I think, 8mm spacers between these mounts. So when you pull the bolt out, this spacer drops out of the way, which is fiddly. But what that allows means when you unbolt all the bolts, because it's sort of built around the engine, the frame is then loose, so I can then jiggle it to bring it away from the bike. Bring the frame away from the engine, because there's overlaps. There's things like a tag here you can see that you have to get the frame around to get it off. And the last thing I wanted to do was to build a frame around an engine and then go, oh no, the engine's stuck forever, and I have to cut the frame in half to get it out. And again, I've met people who've done that when they built things. So the next major sort of operation was making all the frame tubes. So I'd decide where on the engine the original engine mounts would go. There was one there, so I'd make a plate up and then eye up where the tube would go, and then using a very crude pipe bender, bend the pipe, offer it back up to the frame, and then put it on the pipe bender, put it back up to the frame, put it on the pipe bender, put it back onto the frame, and do that like all evening until I got the bend where I want it. And it looks like there's a single bend up in that, but it's not. It's a double bend, so it goes up and then across. So it's quite a complex bend to get right and then get it where you want it. And then because the engine is kind of lopsided because of the pump, I had to make another one that went round to the other side. And it needs bracing up near the top because there's a lot of stress and strain up on the headstock where the front wheel basically is bolted on. You need bracing, and I did that by making cardboard templates, which I then transferred to sheet steel using a pen and then an angle grinder, cut them out. Removed it all so I could weld it, removed it all from the engine, but made sure, as after tacking it all up in place, but because if you're not aware, when you do a big weld on something, the weld is hot, it's molten essentially, and as that chills, it contracts. And if you do a big weld round here, then something here, maybe half a meter away, will move by a considerable amount, certainly enough to ruin the build. So before I welded it up, I welded a big solid metal plate between everything to hold it all in place so it's not distorted as much when it's welded up. And that allowed me to get these brace parts in, making sure they fit really well on all sides, and then weld them up again with a stick welder. And the whole build was really just putting things up in place and taking them away and putting them up and until it was all right. So here, this is the layout, making sure that the ergonomics are right. I got the seat, even though I didn't use this seat, got the seat in about the right place, and the wheel rear is further enough away that it doesn't chafe on the tyre, which allowed me to then right order. Start working on the rear chassis and subframe. So because I can't use the back end of the bike because it is no longer anywhere near anything I can modify. I have to build a new one. So I had to make the rear suspension, which involved turning some hubs, threading them, because I had to tap the right size, so I didn't bother with single point turning. So I ended up with some parts here, and what these are is the bearing, the spacer, the original pin. I didn't make the pin. The pin's from again a BMW, which threads into this slug here, and then this one is the one that will rotate, which should be obvious in the next slide. So those parts form both ends. So there's two pairs, then a shaft in the middle, and this one in the middle obviously spins for the suspension, and then the outer two are the ones that connected to the frame, which is, I should have put this slide up, which is obvious here. So the frame tubes come around the back of the gearbox, and they bolt on using the gearbox mounting bolts, which are strong enough to take the sort of load that it'll be experiencing. And then the rear wheel will be bolted onto the shaft to allow suspension, and that's how I got it around the engine and the gearbox with it being as compact as I possibly could. And it's also copying the layout of the tubes and this bracing support underneath it directly from the BMW frame and chassis outside. I thought, well, you know, if it's good enough for them and that didn't fall apart, then it'll be good enough on here. And I copied the idea. And again, that's the rear subframe, just as a shot to show the bike kind of coming together. And then I had to move on to the actual swinging arm. So again, some much thicker tube because it's not on both sides. So that's 50mm tube with a 5mm wall thickness, really quite chunky. And luckily, my little hydraulic press was able to bend it round. And again, it was an operation because you can't make jigs really. You know, it's not the sort of thing I'd ever 3D model and then try and make it. So it was started off with a long bit of bar, bending it and offering it up and taking it away and bending it, and until I had these two rather cute bends and curves, which were then welded into place to have a rear swinging arm that sort of curled around to allow space for the tyre on it, and of course support the bevel drive, which is the next part. There's 3 or 4 diesel bikes made with the TDI engine, well not the TDI, the 1900 Volkswagen engine, and they've always used an industrial sort of sawmill type bevel drive to turn the the shaft rotation through 90 degrees. And when I've spoken to them and said, hey, how do you get on with that? They've said that it's weak, and one day when they were testing it, they pulled away quickly and basically broke it. So I put a lot of effort into thinking, what can I use as a strong automotive kind of strength bevel drive? And after much searching around, found out that I shouldn't have been looking for bevel drives as keywords on search engines. I should have used the word transfer unit, and then it shows up thousands of, well, not thousands, but many different cars that have a gearbox, and on it some 90-degree transfer unit that then takes the transmission from a two-wheel drive car through to the rear of the car to turn it into a four-wheel drive car. And I did some searching and found one that was looked fairly compact and was freely available, because I don't want to build a bike that I can't get spares for after. And found out that the Audi TT, the S series, all have this little unit bolted onto the gearbox as like an after design. I found a nice cutaway, and what that does is it takes, if you're familiar with the car engine, it has the differential that then drives the right wheel and then the left wheel. And the addition of this unit then takes power out and that way. So you end up with two bolt-on flanges that you would assume you turn one and you turn the other. But there's a slight complication, is it red? The red output shaft connects to a different part of the differential to the yellow gear on the transfer. So because of that, I then had to go out and buy, because I bought just the bevel unit, I then had to go out and buy a whole gearbox, so I could then take the differential apart and remove from the differential one of the little gears and turn down one of the ends of the gearbox, because I've not shown it here, but both those parts go into separate splines within the unit, because those two parts, when they're welded together, then connect the two flanges, which was an unexpected thing I had to do. I thought it would just work with turning one and the other would spin. So that was an unexpected part of it. Other things I had to make was the link, the shaft, sorry, that connects the output of the gearbox to the bevel drive. And of course, there's nothing that will fit. So what I had to do was to get two shafts, one that fitted one end, one that fitted the other end, cut them down, and here they are aligned in the lathe, so they're turned, so they're a nice snug socket fit. And then I covered the bed of the lathe with wood, and then I was able to, with it all lined up in a concentric manner, turn it round and weld it with a high tensile welding rod before I could fit it to the bike. And that worked quite well. Again, the people who've worked with cars will realise that what I have at this end of the bike is a gearbox with a differential with one output shaft coming to the rear. And the smart ones will be saying, well, what's happened to the other end? Is it spinning in free air? And the answer is it's not really. I've known people simply blank it off, so the other end goes around twice as fast, but the center gears of a differential are never meant to experience that kind of rotational speed, and that project failed. So what I did is I took the gearbox completely apart, took the differential out, and then welded up the internal gears of the differential, and then put it back together, and that then allowed the output to all come out of one side and get transferred to the rear wheel. The other, the next technical point was suspension, and I took all the vital measurements. Believe it or not, that's my working notes for the day, and that's got the size of the shock absorbers I had. Bought some competition type shock absorbers. And all the distances, the lengths of the levers in it, and I rung a friend up who had done sort of setting up and design of, I think, Formula Ford. And he said, "Oh, don't worry, I'll tell you what spring you need." So I went out and found the spring that he said, and it was wrong. So I tried another spring, and that was wrong. And in the end, I found a shop shutting down, and I took away 4 or 5 different springs out of his scrap bin, and eventually got one that worked, that was the right weight. So as it bounced without sagging right to the floor or sitting upright, which was hit and miss more than anything. And the gear change was an interesting challenge, because with a car you have the gear lever, and that's on a H pattern, so it goes left and right and forwards and backwards. And how can you do that on a bike? Do you have a clutch? Do you let go of the handlebars? And in the end, after much thought, I separated the 2 movements. So you had left and right, forwards and backwards, and I separated them into 2 levers. One was a toe lever, so as the toe lever does the forwards and backwards, which is, it kind of flows in the way you think, forwards, backwards, toe lever. And then side to side, I had a lever you push with your knee. I didn't take many photos of this when I was building it, but I have one here. That it's probably really difficult to see what's going on, but it has some rose joints, and then it has a bar here that doesn't, probably not showing up too well. That here you've got the knee, and then you've got this lever here, and you push it across, and I did all that with straight levers. Unfortunately, didn't take many photos. The other technical difficulties was finding a radiator that would fit in the space I had available in the frame. And after looking around and failing, because the car radiators are quite massive, motorbike radiators are really quite small, and I needed something halfway. And in the end, I tracked down one of the original sort of 1970s radiators from a original Mini, for 2 reasons. Firstly, it was about the right size, and secondly, it was made of brass. And because it's made of brass, you can cut it and soft solder it. So basically, I cut all and unsoldered all the ports on it, turned it on its side. I even made brass adapters for thermometer, you know, for switching the fan on and off. You know, drilled a hole into this brass end, soldered it in place, and I did all of that, and only had, I think, 2 leaks. I had to fit a fan on it, so I got a fan off a motorbike, made a bracket to go around. Yeah, and you can see how many additions I've made, because there's 2 corner tubes that are in the wrong corners that I blanked off with copper pennies because they soldered well. And because it's a turbo engine, I had to fit the turbo, which is a exercise in plumbing more than anything. Firstly, I had to source, because I wanted an intercooler on it, even though it would work without one. I think I was told the intercooler affects the overall efficiency, and the reason I'm building this is for economy. So I fitted it with I found a intercooler that fitted within the space I had, and then plumbed it in using plumbing fittings, basically. And also because it's the turbo, I needed some sensors, so I then had to make flange plates and things that fitted onto the turbo pipes that take the correct sensors. And because there's going to be a reasonable amount of pressure, I had to put I swaged the tube and put the rib around it. And for that, I converted a pair of mole grips, and I converted it by putting a round in one side and then a hump on the other, and grinding them flat and doing some welding. And basically just went round clamping that all the way around the tube to swage them and get 3 tubes like that, which are all in brass because I wanted it to look nice. Also doing the plumbing, I had to make a fitting in a very tight space. And I'll quickly say that I did that by taking a load of hard drives apart, melting them down in the beam tin with a propane torch in my shed, taking the slug of then aluminium, turning it down to make an adapter that fitted within this space here. Otherwise, it would have been a mess. I was going to talk about the turbo is a VNT, so it's a variable vane turbo, and the pressure of the boost is set by actuating these little levers that move around. And my presentation thing won't show the moving animation of that, which then leads on to the fact that the TDI engine uses a Bosch, because it uses the VNT, the variable vane turbo. It uses the Bosch VP37 pump, which doesn't mean much, but it's a mechanical diesel pump. It's not a common rail one, but it has a fly-by-wire control to it. So there are only wires that go into the pump, so there's no just connecting up to a cable and being done with it. And because of that, you need basically a microprocessor to run the pressure and the fueling maps, which is kind of like a non-trivial thing. And I found a guy, a Finnish guy, I neglected to write his name down, but he's produced a personal project and he's put it up himself. So it's kind of open source. And he produced a project, and he, at the time of starting the build, this was his published schematic. So that's all I had, and some code that ran on a Arduino. And also on his website, he had a little link saying, and you too can build one just like this. And then this as a photo. And I thought, maybe on a car you might get away with that just for testing, but I'm looking at a motorbike which is far more exposed, far more vibration and everything. So I sat down, being an electrical engineer, worked out some proper schematics, and included solve it. I've run out of time to talk about a particular problem, but solved a problem with it, sorted out a double-sided circuit board, which I think I have no, it's my business card. A little board like that, so it's about this big, double-sided, with the Arduino Mega as a core on it, and that's because that's the software he wrote on it. That then controls, this is the pump that's open, and it controls the input via a rotary solenoid, and then this really strange inductive magnetic feedback, which I've run out of time to discuss. And that's me in the street outside my house, reflashing my rat bike. And slightly more extreme, I took it somewhere and I stopped at a lay-by to reflash it because I didn't like the tick over. So it's quite high tech. And on the first shakedown run, because I really pushed myself to finish it. Otherwise, if I'd have finished it and polished it and made it look nice, I'd have been working on it right through to next year. So I got it going as quickly as I could. Went out to an annual show I go to. And won first prize in the engineering section of their show, which I was quite pleased at. And this is just a scenic shot, and I think yes, that's the end of the presentation. So.
And with perfect timing, I must say, 10 minutes for Q&A.
Yeah.
So while you line up at the microphone for questions, did I get this right that you melted down a hard drive to make your motorcycle work?
Yes. Yes, I used to.
You can do that. But the cycle broke down on the way here, so maybe you want to shout out, ask a question about spare parts or something?
Yes, I broke down on the way here. As I said, I broke down despite using the bike every day for several years with not much. I'm sure I've got friends that will disagree with me, but without much problem. I broke down 10 miles away, which was close enough to get here without too much thing. And what I've done is I took it all apart and...
because maybe we have some Dutch-speaking people here who can help you out.
Yeah, I was wondering if someone could help, because tomorrow is Monday, whether someone could come and help me fight through the sort of language barrier of searching for spare parts, because literally in the half an hour before the show, I had dirty hands, I took it apart. This is the injection pump. I took the injection pump apart after watching one YouTube video. The first hit on YouTube for the diagnostics was a guy, Australian guy, who said, "Oh, take the injection pump apart. You maybe got a broken spring." So I took it apart, had a broken spring, and because of that, the pump doesn't return, so the engine gets no fuel. And there's the broken spring again. But yes, if anyone wants to help me out tomorrow, maybe some telephone calls or local knowledge, we can track down where to get either an original spring or a suitable one, and I can go home under my own steam rather than on a wagon.
Where can they find you?
I'm on the Bristol Hack Space, which is over the dike and just to the left,
Okay.
and the bike will be parked there, so, you know.
Okay.
I'll leave my contact number on it if I'm not there. Yeah.
Excellent, excellent. So on to the first question. Sorry for letting you wait so long.
I have a question. How does it sound? Do you have any recordings or?
No, it sounds just like a diesel engine in a car. It doesn't sound any different. It's again, that's a very common question, and I get loads of geezers hanging around me when I stop at garages and truck stops and for coffee, and everyone say, "Oh, let's hear it go," and I start it up, and they all go, "Oh," because it, you know, it is, you know, from that point of view, nothing special. You know, it's not loud. I silence it so I don't get problems with the authorities, and you know, yeah.
The other question I got from people standing around was, why? Why?
Firstly, it's the engineering challenge. But at the end of the day, there's the fuel economy, which you can argue, is it worth the effort of working on a project for 18 months in your spare time, or is it not? But you know, it brings your bills down. It is, and it's a satisfaction as well of using every day a project you've made, because there are so many projects that people do at places like, you know, conferences like this, and in the maker world, that are for the sake of the project, and yet with this one, I use it to go to work on.
So you need spare parts and a spare room in your flat.
Yeah.
So you looked up what you wanted to ask? Perfect.
Yeah, I just checked, but I see the exhaust is pointing backwards, like on any motorcycle.
Yes.
But it's a diesel engine, and you got your dog on the trailer behind it. For the sake of the dog.
Yeah. I've had a look at that, and you know, I had an engine in it to start with that was quite smoky before I changed it, and because you're moving, the dog's head is about here, and the exhaust is down here, and because of the wind, it goes past, and it's not much of a problem. But, yeah.
Any further questions? Come up. Yeah, please.
Interesting project, but wouldn't it be interesting to build an electric motorcycle?
I would. I'd love to. Unfortunately, it would either be a toy for around town, and I've thought about it, and the big problem there is the cost of the batteries and battery management, which to make a 50-mile or 100-kilometer range would be many thousands of pounds. So it would be a huge investment.
Will you be moving next to gas turbines? A gas turbine?
Oh, no.
Why not?
I wouldn't know where to get a cheap one from. I did once have a motorbike with a sidecar on it that I ran from LPG for a few years. That was really interesting and saved a huge amount in fuel price. Yeah.
Any further questions? We have a specialist here. Yes? Take your time. We got a few minutes.
Just one regarding electric motorcycle again, since you looked a lot into regulations. How hard will it be to make a motorcycle like this from scratch, but with an electrical engine instead of?
If you make it from scratch, so certainly in the UK, I think it's obviously different in every country, but in the UK there's something called the MSVA, because of sort of international regulations, everything has to sort of conform to everything else, is about 15 years ago. All the kit cars and self-builds had to be regulated. They brought out this single vehicle approval scheme, which an electric vehicle will have to pass, and in it are is a section on the specifics that you need to have checked for an electric vehicle. So there is no real difference that I'm aware of. A few years ago, I worked with a guy that was making electric cars, and he successfully registered an electric motorbike he made. You know, it had very small range. It was a fun thing, but he successfully put it through the regulations just by filling the forms out and sending it off, you know, and having it tested.
Excellent. Another question, please.
Where do you stand, particularly back in the UK at the moment, as we've got the war on diesel-powered cars and so forth? Where do you stand with that going forwards, and also with our esteemed friend Sadiq Khan in London and emissions?
I stick my head in a bucket of sand. I don't know. It's certainly very interesting. Basically, it's just wait and see what happens. You know, nothing will happen within a few years, so there's not a lot an individual can do. No.
And another question coming up. Perfect. You got good timing.
The most important part, what's like driving it compared to a gasoline?
It's interestingly different. I mean, this little one is sort of underpowered, because most motorbikes are very much overpowered for what they need. You know, even the small motorbikes will exceed the speed limit within seconds. So the one out there is slow to get up to top speed, but not enough to be a problem in traffic or hold people up. And the bigger one is very heavy, so you're aware that there's a big, you're on a big mass, and that is powerful. So it's closer, because I've driven quite a few electric vehicles over the years. Driving the big diesel bike is closer to driving an electric car in power delivery, because it just surges forwards. Whereas with a petrol engine, you get all the power at the high revs and none at the low revs. So with a petrol car, as you go faster and faster, as the revs pick up, you get more and more power. But with a diesel, you get that from the low RPM up. So I find it much more relaxing, because you're not always chasing the revs and the power. It's just there when you need it.
As there is no one else lining up at the microphone, that's another question. Quick one, last one, quick one, please.
You mentioned that your latest vehicle is based around a VW diesel engine.
Yes.
Have you noticed when you take it out on the road that the emissions are considerably higher than when it's on a test track?
And I think on that bombshell, we will finish up. And please give a warm round of applause to Russell.